Welcome, students, to another video lecture with Mr. Knet. And yeah, we're jumping into the world of solving equations. And again, this is an algebraic lesson, so we're going to realize that all of our pre-algebra skills, multiplying rules, adding rules, how to do fractions, how to multiply fractions, all that will matter. So if you're having trouble with any of those concepts, please go back to chapters 1, 2, 3, or 1, 2, and 3 to double check to make sure you understand those skills if you're challenged by them here. So what we're learning today is how to solve an equation with rational coefficients. We're also actually going to solve how to do addition and subtraction problems as well. These are just simple one-step equations. Go ahead and pause here and copy down what you see. Okay, welcome back. So our essential question is, how do we solve equations that have rational coefficients? And we're also going to sneak in there addition and subtraction. So really, again, this lesson is all about how to solve a one-step equation. So the first thing we're going to learn here is the multiplication property of equality. And you may remember from chapter 3 something called the multiplicative inverse. Multiplicative inverse. I wonder what a multiplicative inverse is. If you don't know, go check it up. We need to check our vocab, figure that out. Okay, so it turns out we're learning how to solve equations here. So the first thing we're going to do is we're going to draw vertical lines on our inequality or equal symbol. So the skills we learn now on equations are going to work on inequalities in our future as well. So our goal whenever we're solving an equation is to get x by itself. And what the multiplication property of equality means is that if what I do on the left side with multiplication, I'll have to do on the right side as well. So you're right, that's like that universal math rule of being fair. If I change the left, I'm going to have to change the right. Remember, math's a perfect world. Okay, so to get rid of this 2/3 off our x, we're going to have to use its multiplicative inverse. And the reason we're using the multiplicative inverse is there is the operation of multiplication here. And we're trying to get this 2/3 to convert into a number 1. What number times 2/3 makes the number 1? Yeah, you're right. If you guess the multiplicative inverse, which is just its reflippical, that's 3/2. And if I write times over 3/2 on the left, I have to write times over 3/2 on the right side also. I'm going to draw a squiggly line here, separating the top step from the bottom here. So 2/2, that becomes the number 1. 3/3 becomes the number 1, and 1 times x is just x. Now on the right side, this is fraction multiplication, just like chapter 3 taught us how to do it. So if you need help, go look at that first. So 4 and 2, well, they have the number 2 in common, so we can reduce first. And 2 times 3 is 6. So the solution to this problem is the answer of 6. X equals 6. And that's how we use the multiplication property of equality. Whatever I write on the left side, I'm going to also have to write on the right side. Okay, so yep, you got it. The next lesson, the division property of equality. I'm going to pause here and let you copy that down. Okay, welcome back. So this is really similar to what we just did on the left side. We're going to do it on the right side. And I'd say the one key you have to recognize here is that this only works for non-zero numbers. And that's because if the number is 0, there is no reciprocal. Okay, so we're going to draw a vertical line on our equal sign. And what operation, so this is actually going to be, I'm always going to use the reciprocal, but this is another way it could look on this division property of equality. So what is the inverse operation of multiplication, which is right there in between the -7 and the y? Yeah, the inverse of multiplication is division. So we have to divide this side by -7. And if I write divide by -7 on the right side, I have to write divide by -7 on the left side. Notice I am not going to use this division symbol anymore. We are going to use the division bar as a divided by symbol. This is the way we're going to write it for now. Divided by symbols are that bar. Okay, so I'm going to split my step up with this squiggly line. -7 divided by -7. That's a positive 1. And 1 times y is y. 5 divided by -7. Well, -7 doesn't go into 5. So first off, I know two numbers, a positive and a negative, make a negative. And 5 can't be divided by 7. So yeah, we don't have to make any decimals. We can literally just write -5 over 7. That's the answer. We're done. So the answer to this problem is y equals -5/7. So just to show you, I could have used the multiplication property of equality. And again, that's what I'm going to model here. So this is the multiplication example instead. Same problem done with multiplication. So if we write 5 equals -7y, I could have used the multiplicative inverse. And none of this skill changes. The equal sign comes straight down. These reduce. A negative and a negative makes the positive 1y. And negative times a positive is a negative, and multiplying fraction rules still gets me there. So again, we can either show it as division or we can show it using multiplication. And I have the tendency to use the multiplicative inverse all the time because it helps when fractions show up as your coefficient. So I'm going to have you go ahead and pause here and copy down what you see. These are going to be our 1 steps for how to solve an equation that has addition, subtraction, multiplication, or division. And remember, the word or means only one of them could be there. Go ahead and pause. Okay, welcome back, students. So as you can see, not too many overwhelming steps here. There's one step, and the key in here is we're using the inverse operation. So in this problem, we're going to draw a vertical line on the equal sign. Now that is technically step 1, but I was hoping I didn't have to write that as step 1. We're always going to do that. Okay, so what operation is in between 4.2 and x? Right there. Yeah, it's multiplication. So in this case, to make our multiplication to go away, what is the inverse of multiplication? You got it. It's division. So I'm using that division property of equality right now. And we have to divide by 4.2 on the left. And if I do that on the left, I have to do that on the right side as well. Okay. So 4.2 divided by 4.2, well, that's the number 1. 1 times x is x. A negative and a positive, that's going to get me a negative. And now I'm going to need to do my 4.2 into 52.5 on the side. And again, if you're having trouble on any of these skills, look up Chapter 3, please. It's going to teach you how to do this. Feel free to pause while I'm doing the math here, and you can start checking. I don't have my factors of 42 memorized, so as you can see, I'm using guess and check on the side here. Oh, that was way too big. Let's just make sure this one doesn't fit. Yep, it's 2 times. Notice I'm not going to erase any of these guesses because I may need to use them in the future. Add a 0. Bring it down. And 42 into 2. Oh, that's the 5 I've already used. See, that's why you never erase your guesses. It could help in the future. So the answer to this is negative 12.5. And notice the x stays on the left because it was on the left to begin with. The equals come straight down, and then we're doing the math on that right side. Okay, so we're learning how to solve these with inverse operations. Sorry, I jumped back a slide there. I'm going to have a couple problems here. So please leave space, and I'm going to show you the word problem as well. So go ahead and pause here and copy down what you see. All right, welcome back. Okay, so number 1, we're going to be using our inverse operation here to get rid of the 3.4 on the side with the h. Notice, does it ever say work on the left or always work on the right? No. So what side do we always work on? It's the side with the variable. It's whatever side the variable's on, that's the side we're going to work on. And we're going to see in future lessons, it can switch from the left side to the right. So to help get h by itself, what operation is on the same side as h right now? Yeah, it's this plus 3.4. So to get rid of plus 3.4, the inverse operation of addition is subtraction there. If I write that on the right side, I also have to write it on the left. And I'm going to draw this squiggly line to split my subtraction there. Mathematicians use a notation here. Rather than bring down a 0, they check positive 3.4 minus 3.4. That equals the number 0. So they use that little arrow through it and a 0 up above. H plus 0 is h. Equal sign comes down. 10 minus 3.4. Always line up those place values. It helps. So the answer is 6.6 for that one. Hey, on number 2, we're going to draw a vertical line on the equal sign. And the side we're working on this time is the left side because that's where the variable is. And what we have here is some students get confused. They look at this plus and go, man, I need a minus. But have we ever used an operation behind a number to choose what to use in front of it? So instead, think to yourself, what makes negative 5.4 become the number 0? If you subtract 5.4, is that going to help become a 0? No. So in this problem, we have to add the 5.4 because the way to make the negative 5.4 go away is a positive 5.4. If I write that on the left, I also have to write it on the right. So this becomes the number 0. 0 plus k is k equals, and then we have 8.52. I'm going to leave number 3. No, let's do number 3. Let's do it. You're right. Let's do it. So we're going to draw a vertical line on our equal sign. This will be the last one. We'll do the word problem in class together. So how do I make 6 over 11 become the number 1? What times 6 over 11 makes it become the number 1? Yeah, you're right. It's multiplicative inverse, which is just a fancy word for reciprocal. And notice, a reciprocal does not change signs. The reciprocal of a positive is still a positive. The reciprocal of a negative is still a negative. And we have to write that on the other side also. To be fair, these reduce, and 1 times y is y. On this side, we can simplify by the number 2 first. So the answer is 77 over 3. And we are done. That's it. So again, make sure, please, that you have that word problem example copied down. Any questions you may have, please write them in the question column and ask them in class. It does help. I can't wait to see you. I'll see you soon.